Right. So yeah, I'm going to be talking about AI and machine vision, their role in changing manufacturing, and specifically their role in advanced manufacturing. So I'm going to start by giving a bit of an introduction to the AMRC, who we are, just a very brief introduction, and then I'm going to talk a lot about what our partners are telling us. So I think it's best if I go into it and explain as I'm going along. So the AMRC. We are a world-class centre for advanced manufacturing. We were established in 2001 as a collaboration between the University of Sheffield and Boeing. We were originally looking at how to make machining operations more efficient and better. And what the entire ideology behind this was that it was taking quite a long time to get techniques which were being researched in academia and actually getting them into industry. So what we decided to do was make a direct link with industry so we could take through academic techniques and bring them directly into industry. So applied research is where we're looking at. We help manufacturers of any size to become more competitive by introducing them to advanced techniques, technologies, and processes. So we work with some of the largest engineering firms in the world and some of the smallest engineering firms in Sheffield in order to help bring technology along. So I'm going to talk a little bit about this in the next slide, but we often work across industry as well. So there'll be some techniques in, say, aerospace, which are much more advanced than they are in construction, and we can start to look at lateral translation of technology as well. So that's a lot of what we look at as well. We have over 700 researchers, technicians, and support staff, so a relatively large research centre. We have over 120 member companies, and we bring in over £200 million of investment to this former coalfield. It's Orgreave is where we're based. So where the miners' strike took place, we reinvigorated the area and brought in new investment, new employers, and new research. We are also part of the Rolls-Royce and Boeing Global Research Network. So these are some of the members that we have at the AMRC. There's some very big names in here. There's Airbus and Boeing. There's BAE, Rolls-Royce, Siemens. There's a lot of big companies here. So you have the OEMs, you have the original equipment manufacturers, and then you also have people in the supply chain as well. So we have Footprint Tools and we have Avian-Dar, all these different suppliers. So we cover all ends of the supply chain and the actual end users here. So this is why I want to give this talk today, because we collaborate with all these different companies doing all sorts of different applications in a wide range of industries, and we get a lot of feedback from these members as a part of it. So it's basically it's a dialogue, and what we've learned from this is what high value manufacturing and what advanced manufacturing wants, and what it wants in terms of AI and what it wants in terms of machine vision. So that's what I want to talk about today, because the purpose of the AMRC is to aid UK manufacturing. We're a not-for-profit organisation. We're here to allow manufacturing in the UK to grow and to develop and to become more advanced and more competitive. And the way that we do this is by sitting in this sort of area here, as you're seeing in this slide. We sit in the gap between experimental proof of concepts in laboratories, so a technology being trained and saying this is where we're at, is pretty much proven in a laboratory setup. And we're taking it through those next areas, so taking it through levels 4 to 7 in terms of making it more and more mature until it's ready to actually go into industry. That's where we work at. And the way that we do this is by linking up with academia and with industry. So we'll have this low-level technology coming from academia and say, look, we're looking at doing synthetic data, for instance. We'll do R&D, we'll do proof of concepts, and then we'll work with system integrators, we'll work with software suppliers, and we'll work with the end users and industry in order to make the technology a perfect fit, in order to get it in there as quickly as possible. So that's a bit of an introduction to who we are at the AMRC, what sort of experience and feedback that we get. And I'm going to go into that, the actual detail of that, and what high value manufacturers want from machine vision and AI. So it's been widely acknowledged in recent years that there's a growing need for machine vision in advanced manufacturing. The major driving reason towards this is because we need to automate more in order to be more competitive. There are a few existing sectors where we're seeing massive increases in the desire to have machine vision. So aerospace is one, Pharmaceutical industry is another. There is the rail industry, and there's also construction. So these 4 industries, we're seeing huge uptakes in the use of machine vision. There will be other industries, but these are existing ones where they want to apply more and more machine vision and AI techniques to their existing processes. So these new sectors that we're seeing a lot of interest in at the moment are additive manufacturing. Additive manufacturing is seeing a huge increase in the interest in using machine vision and AI to automate a lot of the inspection processes and a lot of the in situ monitoring processes during the process to make sure that it's perfect first time. Autonomous vehicles are growing in terms of use in public environments such as roads, but also in factory and in manufacturing environments such as AGVs for moving robots around and moving equipment around facilities. There's a very large increase in the desire to have autonomous vehicles in a lot of production processes right now. And composite materials, carbon fiber weave, huge growing area of interest. Carbon fiber is quite difficult to image a lot of the times because it's so black and it absorbs most light coming into it. And there is a very big desire now in order to be able to automate that inspection. At the moment, Airbus with the A350 is predominantly made of composite materials. 52% of the airframe of an Airbus A350 is made of carbon fiber. And they need to be able to inspect this at rate in order to be able to monitor how it's performing in real time, in order to be able to produce more, to reduce costs, and to reduce the lead time to produce their aeroplanes. So finally, there are changes in the existing supply chain, which is driving a need for machine vision adoption. I'm going to talk about that a bit further. But let's think about what high value manufacturing actually want when we introduce a machine vision solution. They want the solution to be flexible. They make small batches of a wide range of components. So they'll make lots of different things in small quantities. And they want machine vision solutions which can adapt to these different applications, whether it's inspecting different components or looking for different features of interest. Indeed, I've got an application later on in this presentation which I'll show you exactly what it is we're trying to do in terms of these flexible machine vision systems. They want their systems to be scalable. Just because of the sheer variability in terms of scale and shape of their components, they want a machine vision system which can image a lot of different components rather than an individual machine vision system for every single different type of component that they do, because space and cost are at a premium in high value manufacturing and don't have the time to make these bespoke solutions for a component. So they need to be scalable, they need to be flexible, and they need to introduce traceability. This is becoming increasingly prevalent in high-value manufacturing, is being able to trace the life cycle of a component through its service, through its production, and actually when it goes off into service. So seeing, for instance, a turbine blade when it's cast, seeing it when it's in its wax mold, seeing it when it's being polished, when it's being deburred, after it's been in the acid bath, and then monitoring it in its life cycle to see how it decays. This is a big area in high-value manufacturing, is being able to trace the life cycle of these components. And finally, they want validation. They want to be able to say that this system will definitely work. A lot of the time, these technologies are being integrated for safety-critical operations, and you need to be able to say with almost 100% certainty, this system won't fail. Or if it will fail safe. It won't send anything bad off into the sky or into production or into a building. It will only ever fail safe and scrap good components. So you need to be able to validate that and have that certainty. Supply chains, changing supply chains. This is a quote from the New Statesman in April. Most governments want to end manufacturing supply chains in pharmaceuticals, antibiotics and medical equipment and revert to national production. This instinct is likely to spread to high-tech sectors, and it means taking away production from China. And the reason behind this sort of shift in approach to supply chains is very well illustrated in this graph here. This is a pie chart showing the proportion of Fortune 1000 companies with suppliers in Wuhan. So it's 90% of Fortune 1000 companies have suppliers in Wuhan, China. They were the first to be hit when COVID-19 took over. Their supply chain was pretty much obliterated overnight. And this has caused a big panic within high value manufacturing is that these supply chains, the longer the supply chain goes on, the weaker it gets, because you're only as strong as the weakest link. So as soon as one link goes down, the supply chain goes down and your end product is hit. So there is a huge drive now within the UK in order to bring supply chains inwards. So can we compete with China? We can't compete with China in terms of the cost of labor, the cost of materials, what they actually do. So we need to look at more advanced ways in order to be able to bring these supply chains internal. And that's what we're trying to address at the moment at the AMRC, and that's what we're wanting to work with people on now. So supply chains are spread out, they're spread out that long in order to reduce the cost for production. How do you reduce the supply chain length? You have to reduce the cost of internal manufacturing. How do you reduce the cost of internal manufacturing? You increase the level of automation that you have in the process. You increase the amount that you can do autonomously. How do you increase the degree of automation? Machine vision. So machine vision in order to enable you to do more complex tasks and allow you to do more operations in a shorter period of time. Now, how do we operate? These are just a few of the areas that we look at the moment. We're looking at automated inspection. So we're looking at assemblies, inspection of components and put together parts. We're looking at product tracing. We're looking at robotic guidance, process monitoring, AI is a massive area, and 3D inspection. So we're looking at all these different areas to see how can they help the supply chain in this country. How can we use this knowledge that we're doing here, and how can we actually transfer that into industry? And we're looking to work with partners, looking to work with end users, looking to work with system integrators and suppliers in order to develop these technologies and actually put them into industry. So I'm going to quickly run through a sample application that we've done with a partner. So this is with a large aerospace partner looking at the inspection of complex fabrications. So these are complex sheet metal components. And what they wanted was basically what I set out earlier. They want a system which is flexible, so it can inspect a wide range of components and look for a wide range of features using the one system. They wanted it scalable so that it could adjust to different size components coming into the inspection area. They wanted it traceable. They wanted to be able to read the data code and the part code in order to see how it performs over its lifetime. And they wanted to be able to validate the process to see how it can be deployed and validated and actually sent into production. So based on this, we developed this proof of concept system. You see how simple it actually looks there. That's actually quite a high-powered camera. I think it's a satellite camera we use there just through membership and equipment. But Rexroth frame, looking down, field of view, looking for components coming into it. And we were inspecting for a wide range of different features. We were looking to check spot welds, checking that they were all in the correct location. We were doing data code reading. We were looking at countersinks. Can we identify them? We were doing dimensional analysis of holes in these sheet metal components. And we were showing this all with the one system, one computer, one program, showing that you can make these systems flexible. You can make them scalable. You can look at different areas of interest. We can do counting, all these different things. So identifying rivets in this field of view, seeing how quickly that you can actually do these inspections. So that was performed in real time, looking at these sheet metal components and saying, look, find these, there you go. Showing how we can do it, how we can do this very, very quickly. So yeah, this is a project that we're currently working on and we're looking to develop further. We're also looking at developing special techniques and taking this further. So this is polarization imaging, looking at surface defects on plate metal. So taking special imaging techniques, looking at the plate metal, taking the original welded images and converting it into its polarized data and trying to identify these specific defects that you see in there. Then using machine vision, using AI in order to highlight these defects as well. All these applications I'm happy to discuss as well further, and my contact details are available, so do get in touch if you want to discuss this further, but I'm slightly pressed for time here. But yeah, we work in low-level technologies. We look to take these further. We look to develop it further and actually work with system integrators and end users to integrate it. So, working with the AMRC. The purpose of the AMRC, as I've said, is to aid UK manufacturing, and we're always looking to for partners to work with. And this can take a variety of forms. We can be collaborating on projects together in order to deliver production-ready solutions. We can demonstrate technologies to our partners if we think that looks valuable. If you have a product that looks good, we can demonstrate it to Boeing and Rolls-Royce and Siemens and Spirit and all these different people. And we can allow for networking to see how we can get this technology into advanced manufacturing. So as soon as the AMRC is open again, when we can take in visitors, I'm more than happy to welcome you to the AMRC for an actual trip round as well. So if you do have any questions, I'm sure there'll be a Q&A at the end, but if you want, those are my contact details there. And do feel free to get in touch if you have any further queries or like anything, any information on these specific applications I've gone over. So yeah, that's my time. Thank you very much for listening, everybody.